Okay, in this video we're going to be looking at the simple machines worksheet, and again there's not a lot of this stuff on the Regents exam, but it's a really good example and a usage of the law of conservation of energy and the law of work. That the amount of work that you put into a machine is equal to the work you get out minus whatever you've lost to friction. So we'll start over on this side, identify the simple machines. So A, that's obviously a lever fulcrum. B is going to be a screw. C is a pulley. D is a wheel and axle. E is an inclined plane. And F is a wedge. And if you can't read it, well, you can at least hear my voice. The main ones that we're going to be concerned with are the lever and fulcrum, the pulley, and the inclined plane. We will primarily just focus our aspects on these two right here, the pulley and then the inclined plane. Over here, kind of matching up mechanical advantage. Mechanical advantage is how much force the machine amplifies or reduces your force. The units for mechanical advantage are none. How far the machine object will move without the simple machine, that's actually the distance of the resistance. And how far the object moves with a simple machine, that's DE, the distance of the effort. With the machine, that is a device that has moving parts and can do work. Okay, it actually transforms the work that you put into it into some other type. Force in is the force that you put into the machine. A block and tackle is another name for a pulley, and the force that comes out of the machine is F out. Now we're going to define what's an input force and what's an output force. If you're lifting a 200 Newton object, that's an input force. You're doing that work. If the wedge applies a 400 Newton force, that's an output force. You push 240 on a lever, that is an input force. If you turn a screw with 30 newtons force, that's also an input. And if a pulley applies 40 newtons force up, that's an output. As far as the distance effort, distance resistance, this is how far you push or how far the machine moves. So in this one, use an inclined plane to lift a car up 4 meters, that is a resistance one. If you use a 10-meter ramp to raise up a car, that's an effort. If that's how much is going in. If two going up 2 meters, that's resistance. Then the resistance you push down, the distance you push down the lever, that's your effort, and how far it moves, that is the resistance part. Now, as far as the units go, as far as the equations, you got to remember that the law of work states that the work you put in is equal to the work you get out. And then if there's any left over due to friction, that'll be the energy that's lost to friction. This is just basically a rewrite of LOCO-E, law of conservation of energy, because remember, work is energy. So we've got a kid pulling on a rope with 20 newtons of force. The block and tackle system pulls up with a 106 Newton box. What's the mechanical advantage? Now, mechanical advantage is defined as how much the machine will increase your force. So mechanical advantage is, since it's going to be your force out over the force in. So in this case, we've got 160 newtons over 20 newtons, and so that's going to give us a mechanical advantage of 8. That means your machine will increase your force, your effort, by 8 times. It says the pulley system has a mechanical advantage of 4. How much force is necessary to pull up a 200 Newton box? So again, mechanical advantage is the force out over the force in. So we've got a 4, and my force out is 200. So the force that I would have to put in that case would actually only be 50. So my force that I would have to put in is 50. Now in each of these cases, this is an ideal machine. We're ignoring friction. So next one, if it takes 100 newtons to push a 300 Newton object up an inclined ramp, what's the mechanical advantage? Again, mechanical advantage is the force that goes out or the force resistance over the force in or the force effort. And that's going to be 300 newtons over 100 newtons. So that gives a mechanical advantage of 3. And now the next one, 10 Newton force pulls to the right, friction opposes 2 newtons. Okay, so this is not a mechanical advantage one anymore. Okay, 10 Newton force pulls up to the right, friction opposes 2 newtons. Object is 20 kilograms, find its acceleration. So we know the force that's going in, 10 newtons. That's what force putting in. It also tells us we have force of friction is 2 newtons. Now remember, we need to find the net force. If we want to find the acceleration, we need to use the net force and then divide that by the mass. So in this situation, our net force, if we have an object and we're putting 10 newtons of force on it, and we're pushing back with 2 newtons, their opposite each other, so they're going to subtract parallel vectors we subtract, so our net force is going to be 8 newtons in this case. So our net force is 8 newtons, and we know that it's 20 kilograms is the mass, so in this case our acceleration is going to end up being 0.4 meters per second squared. Here we've got a 10-meter ramp helping move a 500 kilogram object up 1 meter. What's the mechanical advantage of the ramp? Okay, so in this case, we're going to use the other mechanical advantage here, where we're going to go the distance in over the distance out. So in this case, the force distance in, we're using a 10-meter ramp, and we're only lifting it up 1 meter. So this is going to give us a mechanical advantage of 10. And our last one, if you have a 200 kilogram bag being lifted with a block and tackle, you pull up with 100 newtons, what's the mechanical advantage? Now, we've done this one before. Mechanical advantage is the force we have out over the force we put in. But this becomes a little tricky because it only gives us that it's a 200 kilogram bag. So the force that we're exerting out, the force that comes out, is going to have to overcome the force of gravity. That force of gravity you can find by taking mass times the acceleration due to gravity. So in that case, I'm going to take my 200 kilograms times the 9.81 meters per second squared, and that's going to give me a force of gravity, I'll put it down here, of 1,962 newtons. So now when I put this in, that's my force of gravity, which is equal to the force that it exerts out. So 1,962 newtons, and I divide that by 100 newtons, and I find that my mechanical advantage is equal to 19.62 newtons. So I hope this helps. If you have any questions, don't forget to come in and see me. All right, everybody have a great night. See you later. Bye.